Okay, in this video we're going to discuss about arithmetic sequence or arithmetic progression. So, arithmetic sequence, I'm going to give you an example of arithmetic sequence. A sequence is basically a set of numbers like 2, 4, 6, 8, and so on. As you can see, they have a pattern. There's a pattern between these numbers that relates these numbers from one another, right? And the pattern is +2, +2, +2. That's the pattern. So this is called arithmetic sequence. I'm going to type it, arithmetic sequence, or sometimes it's also called as, or I'm just going to put an or here, or arithmetic progression, AP. So this is the arithmetic sequence, and don't confuse this with arithmetic series, because arithmetic series is different from sequence. Sequence means basically a set of numbers. Okay, you don't really do anything with the numbers. An arithmetic series, however, is when you sum all of these numbers, it becomes a series. So, for instance, okay, so if I do this, so if it were to be 2 plus 4 plus 6 plus 8 plus so on, this would be called as an arithmetic series. So I'm going to write this arithmetic series. So this is called an arithmetic series. And they're both different. So now that we know the difference between these two terminologies, let us move on to discussing arithmetic sequence in this video. So there are three types of arithmetic sequence, actually. In middle school, or maybe in the beginning of high school, we're only introduced to, I think commonly we're only introduced to the first type. So the first type is the most common one. It is, I'm going to write the general formula for this arithmetic sequence. It is the nth term. I'm going to denote that by un. It's a plus n minus 1d, right? Where a is the first term. I'm going to write it in purple. So a is the first term. A is the first term. D is the difference. D is the difference. And n is basically the nth term. So this is the nth term formula for the first type. The second type is a little different. How do we know which type a sequence belongs to? I'm going to give you several examples. So in the example I gave you here, this is easily classified 2, 4, 6, 8, so on. This is easily classified since as type 1. Why? Because you see here the difference is the same. The difference is constant. So it's 2, 2, and 2, right? the difference is constant. The difference between the next term and the previous term is the same, and it is the same throughout the sequence. So this is type 1. Okay, so this is type 1. Now what about a type 2? A type 2 sequence. A type 2 arithmetic sequence would look something like this. 1, 3, 7, 13, 21, so on. How do we know that this is type 2? Well, let's try finding the differences between each consecutive pairs of terms. Okay, so this, let me use a different color. Let me use red. So this, the difference between these two numbers, 2 is plus 2, right? And this is also plus 2. Oh, sorry. This is plus 4. My bad. This is plus 6. This is plus 8. And if we go here, as you can see, these numbers are not equal, right? This is 2, this is 4, this is 6, this is 8. So it is not type 1. So we can continue this. So the difference between these two numbers, there is a pattern between these numbers, right? So the difference is 2, the difference is 2, the difference is 2. Only then do we find that these numbers are equal. So the difference, okay, this looks like a 1. So the difference is now constant, but then it is constant when we've reached the second, I would say second layer, right? So now that it's constant, this is type 2 because we do it twice, right? We do it twice. We do this method twice to get to constant difference, right? So just think of it like this: 1, 2. So this is type 2. Oh, sorry, I forgot to write 2. Okay, type 2. Now type 3 is similar. Type 3 will just go on. You will just have to add another layer, and that becomes type 3. So a type 3 arithmetic sequence or arithmetic progression would be 5, 6, 9, 16, 29, and 41. Now the same process like before, we're going to repeat the same process. So the difference, we're going to find the difference. This is 1. Yeah, this is 1. This is 3. This is 7. This is 13. This is 21. Notice that this sequence is actually this sequence. So if you keep going, you will just end up getting this whole thing right here, right? So this is going to be, I'm just going to copy and paste whatever is up there. 4, 6, 8. And this difference is 2, difference is 2, difference is 2. Finally, we have reached constant difference. So this is type 3 because it's like 1, 2, 3, right? So 3 layers, so it's type 3. 1, 2, 2 layers, type 2, 1, 2, 3, 3 layers, type 3. That's how you classify it. And in the next video, I'm going to give an example of Okay, so I've decided to just merge the videos instead of splitting it into two videos. So I'm going to be giving an example for type 3 arithmetic progression. The idea will be the same for type 2 and type 1. I would like to tell you that we're interested in type 2 and type 3 because these two types are, I would say, a little bit more advanced than type 1. Type 1 is pretty straightforward because we already have this formula, we know this formula. Type 2 and type 3 formula are similar, very similar. Honestly, it can go on to like type 4, type 5. It really depends, like just how crazy the sequence is, right? Maybe it'll go to type 4, but it's very, like, I've never actually seen a problem like that in high school, at least until high school. So yeah, type 2 and type 3. We'll try to discuss these two types, okay? Let me write the nth term formula for types 2 and 3. They're actually pretty similar. So its nth term is equal to, this is for type 2, a plus b. Now I'll tell you in a second what each of those mean. N minus 1 over, can't really draw a line, I'm gonna use the line. So over 1 factorial plus c times n minus 1 times n minus 2 over, over 2 factorial. This is for type 2 because it's type 2, so it only goes up to 2 factorial, up to this term. Now, for type 3, it's very similar because you only have to add another term to the type 2 formula. So the nth term for type 3 AP would be, let me just copy that. I'm going to select all of this. I'm going to copy. Oh, I didn't copy it, I actually cut it. I'm sorry. Okay, I'm going to copy again. I'm going to paste. I'm going to put it here. Okay. And I'm going to add another term. So plus d this time. N minus 1 times n minus 2 times n minus 3 over 3 factorial, right? It can go on, for example, if it's like 4, if you've done this kind of method and it goes until 4 layers, you can add another one here and just plug in the A, B, C, D, E, like that. But that would be, if it was like 4 layers, that would mean you're gonna have a quadratic equation. But because this n times n times, this is a cubic equation, right? So yeah, there's a difference. So these are like different levels, I would say. The first level is just a linear equation. It's just a straight line. Second, this is going to be a quadratic equation. And third, it's going to be a cubic equation. Oh, did I say quadratic equation for the fourth level? If you have 4 layers. If you have 4 layers, it's not going to be quadratic, my bad. It's going to be a, like, to the power of 4, to the 4th power, right? It's not going to be quadratic, I'm sorry. It's going to be quadric, yeah, to the power of 4. So yeah. So that's the trend in that. Now I'm going to show you an example of a type 3 AP. Okay, so the example would be, I'm just gonna write it over here. It's gonna be 2, comma, so let's write here example. Okay, this is the AP. 2, comma 10, comma 20, comma 30. Oh, sorry. I'm just gonna write the 0 better. Comma 68. So we need to find what is the nth term formula for this sequence. Okay. Now, you know, if you see this for the first time, you would think, oh, you know what, I'm going to find the difference between the consecutive terms, okay? So the difference between these two, 10 minus 2 is 8, 20 minus 10 is 10, 30 minus 20, 10, wait, it is 10. I think I made a mistake here. This is supposed to be 40, my bad. Sorry, so that's 40. Just cut that. I'm gonna pause this for a while. Okay, so I've already changed that. So this is an error in the question. So this, the difference between these two is 20. The difference between these two is 30. Oh, sorry. The difference between these two. Oh, wait, that's supposed to be 30 actually. Okay, 1 second. Okay, I really apologize for the mistake before. So we're gonna have to find the nth term. This is the correct series. I miscalculated the series. So yeah, so let's just find the differences between the consecutive terms. This is 8, this is 20, this is 38, right? Now you see here, oh my god, the differences are different, right? We need to keep doing this. We need to keep finding the difference, or the differences, until we reach constant difference. Okay, so we keep doing this. This difference between these two is 12. Difference between these is 18. And the difference between 12 and 18 is 6. Now, as you can see, oh my god, 6 is the last. We can't go, like, there's no other number here anymore, so we can't keep going. So let's just assume that 6, that is our constant difference. Okay? Because we don't have enough terms, as you can see here. There are only 4. So 6 is our constant difference. Now, let us count how many layers there are. This is 1, 2, 3. So this is type 3, right? So this is type 3 AP. Type 3 AP. And the formula for type 3 AP is A plus B. B times n minus 1 over 1 factorial. Actually, you don't really have to write 1 factorial, but that's okay. N minus 1 times n minus 2 over, oh, my bad, over 2 factorial plus d times n minus 1 n minus 2 times n minus 3 over 3 factorial. That's it. So what we need to find the nth term formula will just be these coefficients, right? We need A, we need B, we need C, and we need D. Now, how do we get them? So, in order to get A, B, C, and D, they're actually from here. Okay, so A would be 2, B would be 8, C would be 12, D would be 6. That's all. You just have to remember going from top till bottom. Okay, so from top till bottom, A is 2, B is 8, C is 12, D is 6. Like that. And you can just plug them in. Okay, I'm running out of time. Okay, the video just got cut before because I'm using the free version of Bandicam, so it only lets me record up to 10 minutes. So I apologize for that. I'm recording again. And we were discussing about, the ABCs. So once we have the ABCs, we just have to plug them in. Let's plug them in right now. Okay, let's solve this. Ooh, I'm gonna use white. Okay, so UN, or the nth term formula, nth term is equal to, A is 2, so 2 plus B is 8. 8 times n minus 1 over 1 factorial plus, really sorry for the bad handwriting, C is 12, 12 times n minus 1 times n minus 2 over 2 factorial plus D is 6, so 6 times, this one's kind of long, okay, this is going to be a cubic equation, right? Sorry, not equation, a cubic expression. And this is over 3 factorial. Now for those of you who haven't learned factorial, factorial is pretty simple. So 1 factorial basically means, okay, I'm going to write it here. 1 factorial basically means just 1. 1 factorial is just 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1, 4, and so on. It's basically multiplying the numbers in descending order. Okay? 4 factorial is 4 times 3 times 2 times 1, like that. And n factorial is n times n minus 1 all the way up to 1. Okay, so it's descending. So that's factorial, what a factorial is. Now back to the question. So let's simplify this whole expression, okay? In order to find our nth term formula, right? Once you have the formula, it's very simple. So 2 plus 1 factorial is 1, so 8 times n minus 1. I'm just going to expand it directly, so 8n minus 8. And plus, remember 2 factorial is just 2, right? 2 times 1. So we can cancel those, and it's going to be 6. So this 6 times n minus 1 times n minus 2, n squared minus 3n plus 2. And then the last term, now 3 factorial is just 6, right? So this cancels with this 6. Now we know that, so if that cancels with this 6, I don't have to write 6 anymore. I'm just going to cut this 6 right here. I'm going to use black. Okay, I'm going to cut it. Alright, so n minus 1 times n minus 2, we already got it. We got it here. So it's going to be n squared minus 3n plus 2 times n minus 3. So this is going to be equal to, let's expand them. 2 minus 8 is minus 6 plus 8n. And this 6n squared minus 18n, right? Plus 12. And then plus, let's expand them, okay? Starting with n cubed minus 3n squared plus 2n. And then minus 3n squared plus 9n minus 6. Okay, now all we need to do is just simplify this whole thing right there. I'm just going to mark them. I normally mark like the terms that I've combined in order to not miss anything. Okay, so let's do minus 6. Let's do the n to the third first. There's only one n to the third, right? So we've taken care of that. N to the third. Oh, n squared. 6n squared minus 3n squared is 3n squared. And minus 3n squared cancel. They cancel, so 0. term, n squared term is 0 minus 18n plus 8n minus 10n, right? Plus 2n minus 8n. And I've got, sorry, I think I lost it. What was it again? It was the n's. Okay, we're left with the n's. We have here, okay, for the n's, 8n minus 18n. 8n plus 2n is this. There's 9n here. Okay, so 8n minus 18 is minus 10n plus 2n minus 8n. Oh, okay, minus 8n plus 9n. My bad. I thought they cancel completely. So minus 8n plus 9 is just n, right? And then let's take care of the constants now. Minus 6 plus 12 is plus 6. Plus 6 minus 6, 0. So the constants cancel. As you can see, we've already taken care of everything. We didn't miss anything. And this is our answer. So this will be our final answer. N cubed plus n. And this is our nth term. Yeah. So if you want to try and check, let's see. Let's try and check. Let's try. Let's compute the first 5 terms. First term will be 1 cube, right? So when n equals to 1, it's 1 cube plus 1, which is equal to 2. That's our first term. As you can see, it's equal to this. And then when n equals to 2, it would be 2 cubed plus 2, which is equal to 2 cubed is 8. 8 plus 2 is 10. And as you can see here, that's 10. N equals to 3 is 3 cubed plus 3, is equal to 3 cubed, 27 plus 3, 30. And the third term is also 30. N equals to 4. It's 4 cubed plus 4. Okay, and 4, okay, this doesn't look, okay, that looks more like 4. 4 cubed is 64 plus 4, 68. Right? So, yeah, 68, 68. And we can find even fifth term. Okay, so it's going to be 5 cubed plus 5, which is 5 cubed is 125 plus 530. You can go on. So for example, if the question asks you to find, let's say the sixth term, okay, the sixth term. What is the sixth term? You can just directly plug in n equals to 6 to this formula, and you'll get it. I hope this video has been helpful. Thank you for watching.